We have looked at this set of binomial expansion in our previous video. Now we were forming the Pascal's triangle here, where each number here is the number that multiplies the x, y, the pair of x, y, where you have x to a power times y to another power. And we went up to x plus y to the power of 5, expanding x plus y to the power of 5. So the numbers that multiply the x and y were, as you see them here, 1, and you have a 5, 10, then the next 10 is this, and the 5, then the 1. And you saw that the power of x was the same as the power of the entire binomial expansion, x plus y to the 5. The highest power of x was 5, then it goes down by 1 each time. The next term it went to 4, then 3, then 2, then 1, then 0. And the power of y started at 0 and went up each term by 1. 0, then to the 1, then y to the 2, then y to the 3, then y to the 4, then y to the 5. And you notice that when you add the power of x and y, you get the same number, 5. 5 plus 0 is 5, 4 plus 1 is 5, 3 plus 2 is 5, 2 plus 3 is 5, 1 plus 4 is 5, 0 plus 5 is 5. Now, suppose we want to expand. What we're going to do is continue from here, and we want to expand x plus y raised to the power of 6. What would we get? Based on the patterns that we've seen in the previous expansions and the use of the Pascal's triangle, we can write the expansion without having to worry about doing minutes or maybe over an hour of writing, of multiplying all of those terms and probably making mistakes as we go along. So let's see what's going to happen. You have xy, and the highest power of x will be 6. So let's write it here. It's x to the 6. And let's concentrate on the x's first. You're going to have x to the 5, x to the 4th, x to the 3, x to the 2, x to the 1, x to the 0. Good. Those are the powers of x. What about the powers of y? You'll have y to the 0, y to the 1, y to the 2, y to the 3, y to the 4, y to the 5, y to the 6. Okay, so the powers of x went from 6 down to 0. The powers of y went from 0 up to 6. Now, they all will be added. So let's just put the addition from now. They will add each other. But now, we want the numbers that will multiply each pair of x and y. Which number is going to multiply x to the 6, y to the 0? Which number is going to multiply x to the 5, y to the 1? Which number is going to multiply x to the 4, y to the 2? And so on and so forth. To determine that, we look at the Pascal's triangle. We have it up here. Let me write the 3 a bit further down to get it out of the way. And then we have 1 at each end, 1 and 1. Now, what are the numbers that should be between the 1 on the left and the one on the right. 5 plus 1 is 6, so we should have 6. 5 plus 10 is 15, we should have 15 here. 10 plus 10 is 20, so we have 20 here. 10 plus 5 is 15, 15 here. 5 plus 1 is 6, so we have 6 here. So the numbers, it seems, would be 1, 6, 15, 15, no, not 15 again, 20, then 15, 6, 1. So when you expand x plus y to the power of 6, what you get is x to the 6, y to the 0, plus 6x to the 5, y to the 1, plus 15x to the 4th, y to the 2, to the power of 2, plus 20x to the power of 3, y to the power of 3, plus 15x to the 2, y to the 4th, plus 6x to the 1, y to the 5, plus 1x to the 0, y to the 6th. Good. Now, what I want you to do is to work out what would be the expansion x plus y to the 7th, and we will look at that in the next video.